In this example, we are going to solve for the exact solutions to the equation 4 cotangent of 2x plus pi halves equals 8 in the interval 0 to 2 pi. Then we will find all solutions. What I am actually going to do in this case is I'm going to focus on finding all solutions first, the infinite solution set. Then I will generate the individual solutions between 0 to 2 pi using that. Starting here, we have 4 cotangent of 2x plus pi over 2. So we have a number of things that are operating on x. The first thing that I should do, if I do want to try to isolate x, moving from the outside in, is that I should get rid of that multiplication of 4 that's operating on cotangent by dividing both sides by 4. That will now give me cotangent of 2x plus pi over 2 is now equal to 2. Then, if I want to get rid of cotangent, I will apply arccotangent to both sides, which will now look like arccotangent of 2x plus pi halves is equal to arccotangent of 2. Now, because I'm applying an inverse trig function there, arccotangent, the first thing I'm going to now do is come up with the full infinite solution set based on arccotangent. So this will look like 2x plus pi halves is equal to the infinite solution set for arccotangent. Now, arccotangent works exactly like arctangent does. Whereas you can generate the full infinite solution set for arccotangent, instead of splitting it up into two sets of answers like you usually do for arcsine and arccosine, we can simply just add pi k to this, and now we have the full infinite solution set. Note that I include that addition of pi k now before I continue further to get x by itself, because the other operations I do to get x by itself may also influence that plus pi k. The next thing I will do in this case is subtract pi halves from both sides to get rid of that constant term, giving me 2x equals, depending on how you want to do this order, arccotangent of 2, which I'm keeping as arccotangent of 2 because I don't know that angle measure, minus pi halves plus pi k. I cannot combine pi halves and pi k there because k is very similar to a variable, so it cannot be added with a term that does not have that variable on it. And last thing I need to do is divide by 2 to get x by itself, which means I'm going to divide arccotangent by 2, the negative pi halves by 2, and the pi k by 2, which will now give me x equals 1/2 arccotangent of 2, the inside does not get divided, minus pi over 4, plus now pi k over 2. Or pi halves k if you prefer to write it like that. This would now be my full infinite solution set. And from here, we should now be able to generate the individual solutions. So let's start with the first one listed there. 1/2 arccotangent of 2 minus pi over 4. All right. So let's think, does that fit between 0 and 2 pi? Well, I know arccotangent of 2, since that's a positive ratio, would have to be an angle measure between 0 and pi halves, since that's a positive ratio. If I cut that in half, that means that this now would fit between 0 and pi fourths. Specifically, it's less than pi fourths. So if I have an angle measure less than pi fourths and I subtract pi fourths from that, that is not between 0 and 2 pi. So that's going to be at least slightly negative. Therefore, this first solution would not fit between 0 and 2 pi, we would need to consider adding one instance of pi halves to this to get the first solution. In this case, because I'm adding pi halves to this, I am going to simplify, because negative pi fourths plus pi halves, that just equals plus pi fourths. So I chose to simplify there. That would be my first solution. The next solution would be generated by taking that one and adding another instance of pi halves based on this infinite solution set. Pi fourths plus another pi halves will now give me 3 pi fourths. This, again, 3 pi fourths plus something less than pi fourths. That will fit less than pi, so it's for sure between 0 and 2 pi. If I keep going and add another instance of pi halves to this, this will now be plus 5 pi fourths. That 5 pi fourths plus something less than pi fourths will be less than 3 pi halves, so that's okay. And then also 1/2 arccotangent of 2 plus another pi halves would now give me 7 pi fourths. That's going to be 7 pi fourths plus something a little bit less than pi fourths. So that for sure is less than 2 pi, which would be 8 pi fourths. However, if I add another pi halves, that is now going to go already beyond 2 pi, as I would now have plus 9 pi fourths, which is in itself more than 2 pi. So I am done generating individual solutions. Keep in mind when working through these, as you're getting the number sense for these values using inverse functions, go ahead and approximate these using a calculator. However, if you're going to do that with arccotangent, keep in mind that you would need to consider this as arctangent of the reciprocal of 2, which is 1/2. So you can calculate 1/2 arctangent of 1/2 plus 7 pi fourths in order to approximate that final solution.